Alrighty, kiddos, what we're going to do today is we're going to learn about how to solve triangles using the law of sines. So a couple things we're going to talk about first is let's go ahead and look at, do you remember our triangle congruence postulates? All the different ways that we could prove triangles congruent. So one way is by angle, angle, side. We also had an angle, side angle situation. We had a side, side angle shortcut, even though we really couldn't use that to prove triangles congruent. It wasn't really a shortcut. So it wasn't one of our shortcuts, but when we have this situation, we can go ahead and still use the law of sines. It just ends up being a very tricky situation with the law of sines. So these three shortcuts are your law of sines shortcuts. And the other shortcuts that we have, your side, 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 or your side, angle, side, is when we're going to use our law of cosines, which we'll learn about next week. So law of sines is just a ratio. And so as long as you have an angle and a side opposite your angle, you're able to use it. So like those first two, or for the first several shortcuts, we end up with an angle and a side opposite it, or a way to get a side opposite an angle. So it is just a ratio. We can derive it using just a plain old triangle by dropping altitude from angle C here. That would be our height of the triangle. And if we think way back to just using regular old right triangle trig, if I wanted to figure out what the sine of angle A is, I can say, hey, the sine of angle A is opposite over the hypotenuse. So or side B here in this case is a hypotenuse since it's across from that right angle. The side opposite angle A is our height. So your height over side B. We know sine of angle B is also opposite over hypotenuse, so that's going to be your height over side A. And what we can do is we can solve both of these equations for the height. So when I do that to get height by itself, I just need to multiply both sides by B. So I end up with B times the sine of angle A. And then over here, I'm going to end up with A times the sine of angle B. And because both have our H equals, I can take one of the H's and substitute in either B sine of A or A sine of B into it and just kind of set those expressions equal to each other. So I end up with B times the sine of A is equal to A times the sine of B. And what ends up happening here is that we can go ahead and divide both sides by sine of A, divide both sides by sine of B, or we can also divide by side B, the little b, or side A. And what ends up happening is that we end up with the sine of A over side A is equal to the sine of B over side B. And therefore, also works out then, if we were to drop another altitude so we could get angle C in there, you would also then end up with sine of C over side C. So when we are looking to use our law of sines, again, I've already mentioned we need an angle and a side opposite the angle, or a way to get an angle and the side opposite the angle. We do, to help us out with that, we do use the law of sines for your angle, angle, side, angle, and the side, side angle patterns. Side, side angle we'll be tackling together tomorrow because, again, that's a little bit trickier. We end up with more options. And it's also important to remember that your largest side is opposite the largest angle. And when we're looking to solve a triangle, you're finding all sides and all angles. Or I should say all your missing sides and all of your missing angles. You have to be given 3 pieces of information, so you need to find the other 3 pieces. Okay, so your law of sines is just a ratio. Some people are kind of picky and say, hey, if you want to find the angles, you should have the sign of the angle on top in your ratio. Others, or if you're looking for the sides, you should have the sides on top in your ratios. Personally, I don't care. I tend to cross multiply, so it doesn't really matter if we have all the sides or if you have the angles on top or the sides on top. The important thing is to be consistent so that your ratio is always the same. Alrighty, so let's see how this rolls with just the side angle or angle side and angle side angle situation. If I'm looking here, I do have an angle, this angle B, and a side across from the angle, which means, hey, I know I can use my law of sines. So, I tend to always put my angles on top. Again, it doesn't really matter if you want to put your sides on top. I just tend to always start with the angles. So, sine of 75 over 10, so it's sine of this angle over the side across from it, is equal to sine of 45 over side A. And A we don't know. So what I like to do is I like to cross multiply. So I'm going to go ahead and cross multiply. So I end up with A times the sine of 75 equals 10 times the sine of 45. I tend to round at the end, so I'm going to go ahead and divide both sides by the sine of 75. And then I'm going to put 10 times the sine of 45 divided by the sine of 75 in my calculator all at once. When I do that, I get A is equal to 7.321. If you did not get that, please double check your calculator. I forgot to mention this a minute ago or so. Since our angles are in degrees, you're going to want your calculator to be in degrees. So if you're using your TI-84, make sure you hit the mode button and double check to make sure degrees is highlighted. If you're in Desmos, make sure you go under that little wrench area and change the mode to degrees. Alrighty, so side A is equal to 7.321. We are also missing side C, but we also need to figure out what angle C is. So angle C, when I'm given two angles and a triangle, I know that all three add up to 180. So this is a lot of information that you should be remembering from geometry. So all three angles add up to 180 degrees. So if I add 45 and 75 and then subtract it from 180, angle C is 60 degrees. Now I can set up another ratio and say, hey, sine of 75 over 10 is equal to sine of 60 over that side C. When I cross multiply, so again, cross multiplying means we are multiplying the upper left by the lower right and the lower left by the upper right. And then so I'm going to divide everything by the sine of 75. And I get, when I do 10 times the sine of 60 divided by the sine of 75, side C then ends up being 8.966. Typically, when we're doing anything trig, we do want to make sure we're rounding to at least 3 decimal places. And there you go. The next example works very similarly. Here we do have two angles, and we're looking for two sides. So again, even though we don't directly have an angle across from the side that we are given, we have two angles out of the triangle, so I can add these up and subtract from 180 and get angle C. So when I add 68 and 95 and subtract from 180, angle C ends up being 17 degrees. So I'll put that over here. Angle C is 17 degrees. Now I need to figure out what side A is and what side B is. And because I'm a little bit worried that I'm going to run out of some space here, I'm going to go ahead and do my work on a sticky note. Whoops. Okay, so sine of 68 over side A is equal to, we figured out the angle C was 17, sine of 17 over 115. When I cross multiply, I get A times the sine of 17, and it's equal to 115 times the sine of 68. To get A by itself, we want to divide both sides by the sine of 17. And again, I'm going to pop all of that into my calculator, this right here. We want to round at the end. When I do that, I do get A is equal to 364.694. Now we need to figure out what side B is. And I tend to use the side that I'm given just because it's much easier to have a 115 in my ratio than it is a 364.694. It just tends to be a little bit more accurate. And then honestly, if I've made a silly mistake somewhere throughout the problem, going back and using what I'm given just kind of ensures that maybe even if I messed up part of the problem, I'm not going to mess up the whole problem. So I'm going to do the same thing over here then. So I'm going to use sine of 95 over the side that's across from it. And I know that it's across from it because you have to go across the triangle to get to it. And that's going to be equal to sine of 17 over 115. And again, when I cross multiply, B times the sine of 17 is equal to this, the 115 times the sine of 95. I like to put my constant first so I'm not accidentally finding the sine of some kind of a crazy big angle. Hopefully that just reduces some silly mistakes. I'm going to pop that into my calculator. This just means I've got B by itself. When I pop this in, you should get 391.838. And again, double check this, and if you're not quite getting the same numbers I am, double check your modes of your calculator. You should have everything in degrees since our angles are being given to us in degrees. I know we did a lot with radians for a while. Now we're back to degrees because most of our angles are going to be given to us in degrees. So that is it. The law of sines is just a ratio. I tend to put my angles on top, but it doesn't matter which way you do it, as long as all of your tops have angles or all of the tops have sides, so that it's the same ratio. And now you get to go into Delta Math and practice this a little bit. So any questions about this, I will definitely be going over this again tomorrow, or on Monday rather, with you. And then we'll be doing the ambiguous case as well. So you'll also get a little bit of review that way with it. Have a good rest of your day, and I'll see you tomorrow.